Hi everyone. In our previous lecture, we have covered the method to measure utility through the ordinal approach or the indifference cover approach. In our today lecture, we are going to discuss that what are the properties of indifference curve or IC. As in our previous lecture, I have mentioned that the first property of indifference curve is that indifference curve slope downward to right, and the second property of the indifference curve is that they are convex to the origin. Why indifference curve was sloped downward? Indifference curve was sloped downward because of diminishing MRS or the decreasing marginal rate of substitution. So moving forward, uh, let's discuss about another property of the indifference curve is that higher indifference curve represent a higher level of satisfaction than as compared to the lower indifference curve. As you can see that here we have three indifference curve, IC1, IC2 and IC3. On IC1 we are taking this amount of good x1 and this amount of good y1, and on IC2 we are taking this amount of x2 and this amount of y2, and similarly for IC3 we are taking this amount of good x and this amount of good y. As you can see that on higher indifference curve give us more number of x1 and more number of good y. So that's why we are seeing that higher indifference curve give us higher level of satisfaction. Why? Because on higher indifference curve we are able to take more number of good x and more number of good y. So higher indifference curve give us more and more level of satisfaction as compared to the previous one. The next property of the indifference curve is that two indifference curve cannot intersect each other. Okay, why? As we discussed in our previous property that higher indifference curve give us higher level of satisfaction. So if two indifference curve intersect each other, this is the violation of that property, as higher and lower giving us the same level of satisfaction. So that is not possible. Why? Because higher give us more level of satisfaction and the lower give us less satisfaction. So if two indifference curve, this is the higher one and this is the lower one, if they are intersecting at this point, so it means that higher and lower both are giving us same level of satisfaction, so that is not possible. So this is the fourth property of the indifference curve, that two indifference curve cannot intersect each other. Why? Because if they intersect, so it means that they are giving us same level of satisfaction. So that is the violation of the previous property. The next property of the indifference curve is that an indifference curve cannot be a straight line. Okay, there are two extreme cases in which indifference curve may be straight line or the L-shaped, and that is in the case of perfect substitute and in case of perfect complement. But when the goods are normal, so the indifference curve cannot be straight line. Why is that so? If indifference curve is straight line, it means that on that point MRS is constant. So you are willing to forgo 1 unit of x for 1 unit of y, and similarly goes on. So your MRS is not diminishing. MRS will be constant in case of straight line. So that's why indifference curve cannot be straight line. If indifference curve becomes straight line, so that in that case MRS will be constant, which is the violation of its definition, as we discussed in its definition that indifference curve is diminishing and its slope downward to right, and MRS is decreasing, but in this case MRS is constant. And the next property is that indifference curve cannot be concave to the origin. As we have discussed earlier that indifference curve are convex to the origin. Okay, so if indifference curve is concave to the origin, it means that MRS is not decreasing but it is increasing. So when MRS is increasing, so in that case that is the only possibility for indifference curve to be concave. So it is not possible. as we have discussed in our earlier lecture, that MRS is decreasing. So if indifference curve is in this shape, that is concave to the origin, that is only possible when MRS is increasing, and that is also against the definition of indifference curve, as we discussed that MRS is decreasing. But if MRS is increasing, that will make indifference curve concave to the origin, which is also the violation of the definition of the indifference curve. The next property of the indifference curve, that indifference curve are not parallel to either axis. Indifference curve cannot be parallel to y-axis, and indifference curve cannot be parallel to x-axis. Why is that so? As in our definition we have discussed that indifference curve shows the combination of two goods. Okay, so when and the MRS is decreasing. So if indifference curve is parallel to y-axis, it means that we are keeping constant x and we are increasing the number of unit of y. Okay, as you can see that we are consuming the number of unit of x only 1 unit, and we are increasing the number of unit of y. So that is not possible, as we discussed in our definition, that if you want to increase the number of unit of y, then you must have to reduce the number of unit of x. So when you are increasing the number of unit of y, you cannot keep constant the number unit of x. So that is the violation of the definition. Similarly, indifference curve are not parallel to x-axis. So if you are increasing the number of unit of x and you are keeping the number of unit of y as constant, so in that case indifference curve becomes parallel to x-axis. So that is not the property for indifference curve. If you are willing to increase the number of unit of x, then you must have to reduce the number of unit of y. So it is not possible that you are going to increase the number of unit of x and you are keeping constant the number of unit of y. So you must have to reduce, you must have to forego the number of unit of one good if you are willing to take more number of unit of the other goods. And the last property of the indifference curve is that indifference curve cannot touch either y-axis or x-axis. If indifference curve touch this axis, y-axis, it means that at this point you are taking 0 number of unit of x, and that is not possible, because in definition we have discussed that indifference curve shows different combination of two goods. So there must be two goods. If indifference curve touch this axis, so it means that the other good is 0, which is the violation of the definition. And if indifference curve intersect this axis, that it means that you are taking only x good, you are not taking any unit of y goods. So when your IC touches either y-axis or x-axis, it means that you are purchasing only one good, the other good is 0. So that is the violation of the definition of the indifference curve. So these are the properties of the indifference curve.